today's lesson, the sequence-to-sequence breakthrough that happened at Google in 2014. So I'm going to give you guys a story to kind of conceptualize this. Just relax, listen to the story, kind of try to visualize it, and that'll help everything else click into place. So you're at a coffee shop, let's say it's Starbucks. I used to work there, so I know a little bit of the nitty-gritty about how this works. So go with me here. You walk in, and you order a large black decaf coffee, but extra strong, but still decaf. And the barista says, okay, not the barista, the cashier, but he's new, so he doesn't really know this system. So he's got to look it up in a book. And for each of the things you said, I want a black decaf coffee, extra strong. He's got to look it up and find the tables. And each one's got like a number, and he writes down all these numbers. All right? And because he's new and he's in training, the manager, the shift lead, comes up and says, okay, I'll take it from here. And she takes a clipboard out, and she does these rows and these columns. And for each row, she's got a little solution at the bottom, and she's writing in pencil. And she solves the first row and writes the solution. And then she solves the second row. And she erases what she had, and she writes down her new solution. And there's like 6 rows. And so for each row, she solves it, and she erases and adds her solution. So by the time she's done, she's got the solution for the whole order, which was a big black decaf coffee that's extra strong. And then there's the barista, which is the person that actually makes the drink. And so she goes up to him, and she says, hey, look, here's a cup. And she marks it up based on her solution. So I don't know if you've ever been to Starbucks, but if you look on the side of the cup, there's these little boxes. The first one is decaf. So in our example, this one's marked. The second one is syrup. So in this one, they wanted vanilla, so it's got a V through it. The next box is shots. What that means is shots of espresso. So normally, a regular black coffee is going to get 2 shots of espresso, actually. And this guy wants it extra strong, or you want it extra strong, so they're going to do 3. So they're going to put a 3 in the shots. And then the next box is the name of the drink. So this is an Americano. You guys probably know the story. When American soldiers were fighting in Italy in World War II, they would go up to the cafes, and I guess they were pretty good customers. But the Italians drink coffee like little shots of espresso, and they kind of sip it. Whereas I'm from the United States, so I much prefer the American-style coffee, which is basically watered-down espresso. You take a couple shots of espresso, and you add water, and now you have an Americano. So that's the story of why it's called an Americano. But I digress. So they put a big A at the bottom of the cup in the box for drinks. Now, the barista, the guy working in the bar, he only sees these markings on the cup, okay? He never hears you ordering this big black coffee, doesn't know, doesn't care. He just sees the markings on the cup. And so he says, okay, we've got decaf. So let me go get the decaf beans. All right, and then he makes tamps the espresso. Now they have automatic machines. Anyway, he makes 2 shots of decaf espresso for you. And he puts them in the cup. And he's like, okay, what do I have now? I've got 2 shots of decaf espresso. What's next? It's got a V under syrup. So that's vanilla syrup, because you want a vanilla one, right? So he goes and he finds the vanilla syrup under there and pumps, and he pumps 2 pumps of vanilla syrup. And he says, okay, what do I have now? I've got 2 shots of decaf and 2 pumps of vanilla syrup. And what else was there? Oh, yeah. What else did the guy want? What kind of drink is it? It's an Americano. So that means I need to add hot water. All right, so now he goes and he waters down this espresso with 3 shots of decaf, I'm sorry. And he says, okay, now we got 3 shots of decaf in this cup. We got 2 pumps of vanilla syrup. And we got a lot of hot water to water it down. Let me check the markings. We got decaf, we got 3 shots, we got vanilla syrup, we got Americano. We don't have any milk because the milk is blank. We're done. We can put a lid on it, right? And he takes the lid and he puts the lid on. And now what he does is he calls it out. Now, if you've been to Starbucks, you know this. You better watch the bar and wait for your coffee. And they're not going to call it out in a way that you're used to. For this drink, he's going to call out decaf triple venti, triple vanilla Americano. And you better be on the lookout for that. Now I think they've kind of reformed the system, and they ask for your name, so they call your name. That makes it much easier. But the old school way is to say triple venti, decaf Americano. And actually the order is very important there. And they call it out. And you better understand what he said if you want your coffee. Now, why did I go through that meandering story? A lot of reasons. We're not going to go into them all. But if you can follow that, you can follow how this AI started to take shape in 2014. So, we're going to go into more detail now. This paper that was published by Google was by Sutskever et al. In 2014. Anyway, we got the paper here. Let's see, let me get out of the way. Sequence-to-sequence learning with neural networks. So we have to learn this paper. And that's what we're going to be doing today. And we're actually going to be recreating this in the code that you have. All right, so you can download this paper on Archivex. All right, I can't include it in the thing because I'm not licensed to do that. But we've also got the README here that will walk you through this paper. At some point, I want to get the translations for you guys. I know a lot of you guys speak like Polish or Slovak or Ukrainian or Hungarian, but I'm not quite there yet today. We'll get there. Anyway, I digress. So you've got the too long didn't read summary here that we just went through. It's important to kind of like repeat that summary, visualize it, and conceptualize it, because this is pretty hard stuff. And if you can just visualize the scene I told you about, it'll make a lot more sense. Depending on your profession, it might make more sense for you to think about like a doctor's prescription or a mechanic's work order. But for me, as an ex-Starbucks barista, the coffee addict, the Starbucks one made the most sense. And now right here you've got the more deep explanation. So I'm going to go through that with you guys because it's really important that this clicks for you guys if you want to become all-star AI engineers. So if you remember the lesson on vectors, if you haven't done the lesson on vectors, word2vec, you really want to do that because this stuff is kind of cumulative. But if you're an overachiever and you skip the lesson on vectors, a vector is basically a list of numbers, and every word in these systems gets a vector, becomes a list of numbers. Now, these numbers aren't random. They're learned numbers, which means they're weights. We'll go into that in a second. But to go with the Starbucks metaphor, how do we know what number goes to what word? Remember the new cashier? He looked up in the notebook, and he found the word for decaf. All right? And it had like a number 3. So he writes 3. And then he's like, okay, the decaf is in, let's say, locker number 3. Imagine in back in Starbucks, they've got all these lockers. They don't, but just go with me here because it'll help you learn this system. So they put the decaf in locker number 3. They put the vanilla syrup in locker number 5, for example. Now, let's go to the decaf beans. They're in locker number 3. And the locker has like a combination lock, which means you have to enter numbers in the exact right order to get it to open. If you went to high school in the United States or middle school, you probably had those lockers like for a gym. We did at least. Anyway, so way back when, during the training phase, corporate spent a lot of money to decide, to figure out, to learn, machine learning the best combination for each of these locks, for each of these safes, and for each of these lockers. And they did. And what's interesting is that it turned out that things that were similar had similar combinations. So, for example, the cinnamon syrup and the vanilla syrup had similar combinations. The decaf coffee and the regular coffee had similar combinations because they're both coffees, right? What else could Starbucks have? I forget. The cups, right? The cups ended up having similar combinations. Okay, so everything's in locker, in safes. Each safe has a combination lock, and you have to know the combination. And you learn the combination, the ideal combination, through training phase. Okay? And they did this. Every store does this. And to make a long story short, these ideal combinations are in this notebook that the cashier looked up. Right. What's next? Yeah, I wanted to talk to you guys about learning here, machine learning, and weights, right? So these values that are learned are called weights. Listen, when you go to the gym, a new gym, you have to learn the weights because the machines are different at each gym. So 100 pounds on one machine is not this at one gym. It's not the same as 100 pounds on another machine, another gym. I mean, okay, there's some guy in there like, yeah, they're the same, but no, like you have to learn your limits on each machine. So it's your first day at the gym, at a new gym. You go to the bench press, right? So to learn the weights, you're going to set it to 100, for example, 100 pounds, which is like 50 kilograms. And you're going to try. And let's say you're really strong, so 100 pounds or 50 kilograms is too easy for you. You say, okay, well, let's try 200 pounds, or which is like 100 kilos, right? So you try 200 pounds or 100 kilos, and that's too heavy for you. So you say, okay, well, let's drop to 150 pounds or 75 kilos. And then you try, and that's too easy. And you say, okay, let's go up to 175 pounds, or like whatever that is in kilos, 80 kilos or something. And you're like, oh, that's a little bit too heavy. So then you're going to drop to 160, which is like 80 kilos. And like, oh, that's perfect. And then you're going to go up to 70 and be like, oh, that's too much. Okay. So now 60 is your weight, your learned weight for the bench press for this gym. And now you're going to go to the lat pull down. You're going to do the same thing. You're going to try with 100. It's too easy. Okay, so now you're going to go to 200. That's too hard. Now you're going to try 150, and that's too much. And then you're going to drop down to 130, and that's going to be great. And just to make sure you got it right, you're going to go up to 140, and that's going to be too much. So now 130 is your learned weight for the lat pull down, okay? And you might do the same thing with the leg extension or whatever. So these are how we learn the weights. And that's how the machine learning works, actually, through that trial and error. So, for every word, we have a sequence of numbers, which is like the combination on a safe. And these are learned through a very expensive process called machine learning, which is kind of like you going to the gym and learning the weights. So we have learned weights for each number. What do I want to say? Okay, so the cashier looks up, and this is the book of learned weights. The vector, that is the combination of numbers for each word in this order, which was large coffee, decaf, large coffee. It's extra strong, right? Extra bitter. So extra espresso. And then the shift lead comes over, right? And she's helping out the new cashier. And what she's doing is called a hidden layer. So what we have is the input sequence. Yo, I'd like a extra strong black coffee that's decaf. And now you got the embeddings, which is where we write down the numbers for each of these words. These are called embeddings, right? Because you can think of it as, we can say in English, putting something to bed. Yeah, you're embedding it, you're putting it to bed in this sequence. Another word for embedding, and another word for embedding, another use of the word embedding in English, if you remember during the Iraq Wars, was they would talk about embedded journalists, where the journalists would be in the military unit, and they would be embedded, okay? So, but embedding here in machine learning, it refers to taking the word, finding its identifier number, its ID number. I forgot to tell you, each word has got like an ID number. So let's say there's 1 million words in the dictionary. It's not 1 million, it's 100,000 words in the dictionary, for example. The word for coffee might be word 2025. That's its ID number. And then next to the D number, we're going to have the embedding, which is the vector, which is this long combination. Okay? You really need to do the vector lesson. We go through all this. But to make a long story short, the vector is a long combination of words, of numbers. So we got the embedding. The notebook is the embedding table. Cashier looks it up in the embedding table, right? Shift lead comes, the manager comes, and she's like, okay, I got all these numbers here, and I have to solve this problem, get the solution to hand to the barista. So she does these mathematical equations, and this process is called long short-term memory, because the solution that she comes up with after she processes each row is like a memory for the order. And it's a long short-term memory. That's like nerd speak for it, because we're going to go through each of the words and we're going to update our solution after each word. So it's like a long short-term memory. All right? So after she does each word, she does her mathematics, she solves word 1, decaf. And then the next word is extra strong. Okay, so she looks it up and she does the solution, and she erases her old answer and writes in pencil her new answer. And this answer is called the hidden layer that gets updated after each word. It's a hidden layer because you don't see it. The guy ordering, the cashier doesn't see it. The barista doesn't see it. Only she's seeing it. Okay? And so she solves her math for each word on her notepad at the end of the clipboard in pencil. And when she's done, she says, okay, I have this solution here, which is basically just a list of numbers, right? It's a vector. It's a list of weights, right? We talked about the learned weights. So she's got this long list of numbers, and when she has this solution, she's going to take the cup and she's going to mark it. Like we said, she's going to put an X to the decaf box. She's going to put a 3 on the shots box because we're getting 3 shots of espresso. Because this is extra strong, right? She's going to put a V through the syrup box because the guy wants vanilla syrup, right? And she's going to put an A through the drink box because the guy wants an Americano. Leave the drink box, the milk box blank because the guy doesn't want any milk. So she marks this cup and she hands it to the guy at the barista who's going to make the drink. Okay? These markings are the hidden layer. Okay? The barista is the output layer, is the output sequence. He's going to make the drink. So let's say we're translating from English to Spanish. Okay, in this metaphor, the guy ordering the drink is the English, and the guy making the drink is the Spanish, all right? We take the English and we encode it into this sequence of numbers, which is the input sequence. And then we transform it into this hidden layer, which is the hidden, which is just a list of numbers that we eventually solved. And now we have the output layer. The guy's making the drink, or the machine is making the Spanish sentence, okay? So the guy working at the bar looks at the drink, he's got these markings. The markings are the hidden layer. And he's like, okay, we're going to make the drink. We're going to do the thing. He says, what do we need first? We need decaf coffee. Let me get the decaf coffee. And he says, okay, we got the decaf coffee. What do we need next? We need 3 shots of espresso, 3 shots of decaf espresso. Okay, let me make 3 shots of decaf espresso. He makes the 3 shots of decaf espresso. And he says, okay, I've got 3 shots of decaf espresso in this cup. Now, this is very important, that the guy making the drink is always looking back and asking himself at every step along the way, what do we have so far? We've got decaf coffee, 3 shots. This is called recurrence. He's always going back and asking himself, what do we have? Okay, so we've got recurrence. Because it's recurringly something he's going back to. So in this architecture, it's very important that when we're making the drink, or making a sentence in Spanish, we're always looking back at what we've built so far. So what's next? Vanilla syrup. It's like, okay, 2 pumps of vanilla syrup. It's like, okay, we got 3 shots of decaf espresso, 2 pumps of vanilla syrup. What's next? water. We add the water, and we're always going back and seeing what we have so far. And then he says, okay, we got 3 shots of a decaf espresso, 2 pumps of vanilla syrup, plenty of water to water it down. What's next? Oh, we're done. All right, and then he puts on the lid, and he calls it out. When he puts on the lid, we've got what's called like an end of sentence token, an EOS, an end token. The lid is like ending it. All right, you're going to see this farther down in the code. And we're done. He calls out the sequence, decaf Fenty, triple vanilla Americano. And that's Starbucks speak. That's our output sequence. All right? If we were doing from English to Spanish, it'd be pretty much the same. So you come up and you've got your sentence in English. Yo, I'd like a black coffee. Then the manager comes and you look up all the words right in the table, and then the manager does the equation in the hidden layer to solve for it, and then the bar builds the sentence word by word. Yo quiero negro café, right? I want some black coffee. And as he builds each word, yo quiero, yo is the first word. He's like, okay, we got the word yo, then we got the word quiero, which means want, right? You guys must know this. There was those commercials, yo quiero Taco Bell. Yeah. If you're from Europe or from outside the States, Taco Bell is like a Mexican fast food restaurant. So, yo quiero, and then café. Con leche, for example, with milk. So you're always looking back at the whole sentence. Okay, so that's called sequence-to-sequence decoder-encoder model. Okay? The encoding is when we're getting the original order. Hey, I like a triple, a black coffee that's extra strong with vanilla syrup. Okay, that's the encoding. Then you got the hidden layer where the manager's doing the math, and then you got the decoder where the guy is making the drink. Okay, so we got a sequence-to-sequence decoder model. Now, why don't we try it out? I know I rambled for a while, but it'll save pain in the long run, believe me. So if you click this button here, make sure you're on lesson here, lesson 4. I can move around these lessons later, but for now it's lesson 4. Sequence to sequence, so that's Seq2Seq, sequence to sequence. And just hit this play button here and watch what happens. Okay, it's going to warm up, and it's going to do the thing. It's going to be really cool. So it's actually going to do this machine learning thing. Tiny Sutskever style sequence-to-sequence Seq2Seq translator. The core idea: compress a whole sentence into one vector, which is a list of words, remember, then unfold that vector back into a whole sentence, like a coffee shop. The cashier reads the order, the manager boils it down to a clipboard, and then marks the cup, and then the barista makes the drink from the cup alone. All right. Step 1 is we're going to make the demo repeatable. So we've got a random seed, which is, we're not really going to randomize the numbers. We're going to have a seed, so the random numbers are the same. And if you notice, people usually do 42. And if you're a sci-fi nerd, that's a nod to The Hitchhiker's Guide to the Galaxy. Some of you guys might have seen that. Okay, yeah, here we go. Here we got the main. Yeah, whatever. Hit enter. All right. So step 1, we build the vocabulary, which means each word needs an identifier number, an ID number. This is usually an integer, so that means like a whole number. So in our example, the word cinnamon is 0, coffee is 1, full calf is 2, half calf is 3, no calf is 4, one shot is 5. Shot, they mean shot of espresso. Vanilla is 8. Target word EOS here, that means end of sentence. Remember we talked about the lid, the barista putting on the lid? So that's going to be the end of sentence. We've got the start token here. Americano, cinnamon decaf, blah, blah, blah. So in the source language, for example, just normal talk, hey, yo, I'd like a strong black coffee. That's going to have a different set of, a different dictionary than the target one, which is like the barista speak. So if the source is English, we're going to have our own dictionary here, where each word's going to have its own number. And then if we were in Spanish, that would have its own dictionary, where each word has its own number. Okay, then hit enter to keep going. So we've got a source language word going to an ID. Yeah, that's like a dictionary. Each word's got a number. And in the next one, we're going to learn the vectors for each word, like the combination. Remember, we had like each thing in a lock and a combination for each one. So now we're going to learn the combinations through machine learning. The reader, which is the encoder, that's like doing the work of the cashier. And then the writer, which is the decoder, is like the guy making the drink, that's the barista. Okay. Hit enter. And now this is actually doing the machine learning on your laptop, which is pretty cool. I mean, we've only got like 10 words in each language, but it's still pretty cool. Okay. You've got each epoch here, which is when we go through the whole training material. It's called an epoch. And then the loss is, it means like how many mistakes do we make? Loss means wrongness. So we want the loss rate to go down. And it does. It starts at 100 and then it goes down to like nothing with our little toy example here. All right. Step 4, run inference. Inference is like when we translate into the target language. So we translate into Spanish, we're doing inference. When we make the drink, we're doing inference, okay? So inference is where the machine kind of gives you your output. For example, we've got a custom order, 2-shot half-calf vanilla coffee. So we're going to look up 2. Shot is 7, half-calf is 3, vanilla is 8, coffee is 1 in our dictionary above, right? And then we're going to get the vectors, and then the manager is going to calculate for each word the hidden state. She updates it after each word, and this is her final solution. Okay, and she uses this to mark the cup. And now the barista, and we can call that the writer, the decoder. This LSTM means long short-term memory, so that hidden state. This final solution is called the LSTM, long short-term memory. All right? And then we're going to make the drink, and this is very important, one step at a time. So first thing we're going to look at is the marking for half-calf. So for that, right, you might do 1 shot of regular espresso and 1 shot of decaf espresso. Now you have half-calf, 50% the caffeine. All right. So double means 2 shots. So we got 1 1 decaf, 1 regular. We've got vanilla syrup. I got ahead of myself. So it's very important. At each step, we have to recount what we have. So we can say, okay, we've got a shot of espresso, we've got a shot of regular espresso, and a shot of decaf. Okay, that's the end of that step. And now we've got to put in the vanilla. So we're going to put in vanilla. And we stop and we say, okay, what do we have? We've got 2 shots of espresso. 1 is regular, 1 is decaf. And we also have 2 shots of vanilla coffee. This is where we get the recurrence, where we keep checking what we have at each step. All right? And what's next? Now we've got an Americano, so we need to add the water. And we're going to add the We say, okay, now we've got 2 shots of espresso, 1 decaf, 1 regular, 2 pumps of vanilla syrup, and we have a lot of water. So we've got an Americano. Okay? And now we're done. So once we're done, we're going to put the lid on it, which is like this EOS marking right here. And then we're going to call it out and say, okay, cool, we got a half calf, double vanilla Americano. All right? And we did it. We did the thing. And here's the math if you want to look at for the half calf single Americano. You've got the final hidden state here. And you can go through step by step to the solution. And that's it. You can also, the principle is the same with English, Spanish, right? So we've got the Spanish word. Each Spanish word gets an ID, which means like an integer, which means like a whole number. So agua is 0, amo, which means I love, is 1, café, which means coffee, is 2, enchiladas, which is like every American knows what that is. Quiero, which means I want, which is 4, and Taco Bell is 5, which is the Mexican fast food in the States, or Tex-Mex, I have no idea. Tacos is 6, and yo, which means I, is 7. Okay, and then target language, we've got a number for each English word here. EOS, again, means end of sentence, which is where we finish the sentence, like putting the lid on the coffee, right? All right. And yeah, it's the same system. We train the model here. The loss rate goes down. Look at that. With each epoch. Each epoch is when we go through the material. And look, it works. You just did machine learning. Yo quiero. My Spanish teacher in high school is from Puerto Rico. So we learned the pronunciation yo instead of yo. So I want yo quiero tacos. In Spanish is our input sentence. We've got the hidden state here, which is like the clipboard, which is, remember, the manager was solving it and doing the math. So for each word, yo quiero tacos, yo, and then we have a solution, and the hidden state, and then quiero, and then we update the solution, and then tacos, we update the solution again, and then we've got that one final hidden state vector. All right, and then we're going to decode it into Spanish. So we encode it into this vector, and then from English, we encode the English into the vector, and then we decode the vector into Spanish, the hidden state into Spanish, right? And we get I want tacos from is our English phrase, and Spanish is yo quiero tacos is what we started with. And we build this English sentence from the hidden state one at a time. So we've got the first word is going to be I, all right? And then want, and so we have the recurrence. So we're going to say, okay, now we've got the word I, and then we've got the word want. And then we go, I want. We've got I want. And then we're first step through, and we say, okay, we've got I want, and what goes next? Tacos goes next. It's going to guess the most likely word that goes next, basically. And now we've got I want tacos. And then it goes, okay, I want tacos. What's next? Nothing. We're done. So we're going to put this EOS at the end. This EOS in the arrows, which means end of sentence. So I want tacos, end of sentence. And we are done. And you can do the same thing for I want enchiladas. Okay, that was a lot today. You can go back and re-listen to the explanation. Just kind of think about the metaphors. And then what's good to do, once you've kind of got the metaphors in your mind, is to go through the code here that we just ran by pressing this button here. You have this code. If you're a ByteClub member, you have this code, and you can just go through this code and really just kind of meditate on it. The whole story, the summary is here. It starts with this metaphor about the coffee shop, very simply, and then in more detail. And then you've got the examples here with the embedding table. And the actual live code is right here, starting on line 122, that you run when you hit this button. So it's good to kind of get your feet wet and sit with this code and learn it and kind of internalize it. Play with it. Like, just change stuff and see what happens. You might be surprised. Try to change something. For example, you can change these print statements here. But what happens if you, change the start to 2? You can just kind of play around and troubleshoot. Get your feet wet here. Don't be afraid of this code, okay? And it's not all going to make sense today. Not all going to make sense tomorrow. But the main thing is to just slowly internalize it step by step. You get a good night's sleep, and it'll start to click more and more and more. And one day you wake up and you just realize it clicked, and you're done. Okay. So have fun with this code, guys. You've got the study guide here for Sutskever 2014. That's the paper from Google that you're going to be mastering. Okay, you can read this as well. This is kind of meant to be an introduction to this paper for people from all walks of life. So you can really learn it. And then when you're feeling brave, go to Google and type in the paper. And they have the paper up for free download from, I think, ArchiveX. So you can go and download it yourself. I can't include it in the repo in the ByteClub, unfortunately, because that would be against the license, so I'm not going to do that. But you can definitely download it here. And the URL to download it from there is going to be in here, or I'll make sure it's in there so you can download it. Okay. Well, you made it this far. You really deserve a break. And so do I. We've gone through Sutskever 2014 with the sequence-to-sequence. That's Seq2Seq. That's Seq2Seq encoder decoder model. All right, and with that, you're getting a grasp on the fundamental technologies behind ChatGPT, behind a lot of the artificial intelligence out there. And so what we're doing is we're just building step by step, sequentially. We're getting a handle on the technology behind artificial intelligence. And that was plenty for today. So, to recap, we've got this coffee metaphor. Go in, order the coffee, say, yo, I'd like a strong black coffee that's decaf with some vanilla syrup. The guy looks it up in the book, and he writes out the numbers for it. And then the manager comes, and she does the math for each row, for each word of your order. And she marks up the cup, and she gives it to the barista. And the barista makes your order one step at a time, and he recaps where he is at each step. And then he calls it out, and he says, triple venti, decaf, vanilla Americano, which is your translation into Starbucks speak, all right? From your input sentence of, I'd like a strong decaf black coffee. I know I beat it to death, but it's the only way. Well, thank you for your time, guys. Go out there and, get some rest. Go for a walk. Treat yourself. You deserve it. And then go through the code, go through the explanation here, and go through the code and hit this run button and run it for yourself. And press enter to follow through, okay? And then you've got the study guide for the paper. Read that, and then go, if you're feeling brave, read the actual paper. That would be great. All right. Thanks so much. Congratulations. Peace out.